guys? It's your hacks, and hopefully everyone's doing good. Today we're going to be talking about the Log4j vulnerability. So hopefully everyone knows what the Log4j vulnerability is. If not, we're going to go over the Log4j vulnerability, and also basically I'm going to try to demo it to you through a TryHackMe lab, which they recently just published. I recommend you to go check it out if you want to do it with me. So, what is the Log4j vulnerability? So, the Log4j vulnerability was discovered very recently, and the Log4j vulnerability basically allows remote code execution by simply just typing a specific string into a text box. So, this Log4j vulnerability basically allows remote code execution, and remote code execution means we can remotely execute commands in the victim's machine. So second, some big companies like Apple, Steam, and Twitter have been affected because they were using the vulnerable version of the Apache Log4j. So basically, loads of big companies like Apple, Steam, and Twitter, many more though, were recently affected a lot because they're using the vulnerable version of the Apache Log4j. The Apache Log4j is actually is an actual framework, which is basically a logging framework. So basically, logging not like logging in like login pages. It's like logging basically is like just like all the logs, and it used to store all the logs. And this framework was made by Java and hosted by Apache. This is like a very top tier logging framework. So loads of big companies use this, but this vulnerability affected loads of big companies because loads of people were using this framework to log their just activities and stuff like that. So how this was discovered is a cloud security team of Alibaba and some LunarSec researchers. LunarSec is like, pretty sure it's a blog type of thing. It's a blog company. So they, cloud security team of Alibaba first initially found this Log4j vulnerability, and the LunarSec researchers found it through Minecraft. So because Minecraft also runs on Log4j vulnerability, so the Minecraft Java edition, they found this exploit through this vulnerability through Minecraft, and basically they found it and they discovered the Log4j vulnerability, and this vulnerability had a CVSS score of 10 out of 10. And basically, CVSS score means a common vulnerability scoring system. So this is basically like how you score the vulnerabilities. So say if it's like a 10 out of 10, as this is, it's staged as very critical, and this basically indicates that this vulnerability is a very critical vulnerability. So say if someone basically who's not in the tech industry and may not know what basically this Log4j vulnerability is, I found this a really amazing quote online. So basically it goes like this. So basically it's supposed to help the people who like don't know about Log4j vulnerability, but like to keep them secure and stuff like that. So basically the Log4j vulnerability is basically your car, and you have the keys to it. So you locked everything inside it, you turned it off, all the windows, all the doors and stuff like that. But you're giving access to people outside who can remotely access your car via Alexa or Siri to drive it, to open the windows and stuff like that. So basically this is what the Log4j vulnerability is. This is in like very like non-techie terms for people who like might not know what tech like in tech terms. So this is a nice quote to tell your grandparents or parents or something like that. So um CSPs, which is cloud service providers, um backed this up. So they basically were they they secure the people who are using the cloud infrastructure. Basically, I know that I read somewhere that GCP, Cloud Armor Security Policy, slash the WAF rule, um, tried to mitigate, made a policy to mitigate the Log4j vulnerability. So basically, say if you are running Log4j, but like the X, but like it would try to protect you from the vulnerability. You say if you are running Log4j and like you're trying to do it for the logging purposes and stuff like that. Say if some outsiders, hackers, try to attack, this GCP Cloud Armor Security Policy will try to stop that. I mean, not try. It will block. It will detect and block the Log4j they're trying to access. And basically, I'm pretty sure loads of other cloud service providers like Azure, AWS, and many more have done the same thing. So that's good. But say if you are like a small business, or not even small, like, but you are not with a cloud service provider and you're on-prem. So basically meaning that like you're not with the cloud service provider and you run log4j for your logging purposes. This is a very um, a critical thing for you to do, because many hackers will try to scan for people who are not using clouds, as they found out that loads of CSPs, cloud service providers, have already mitigated this. And say if you don't use it, it's a really big threat. So you should like make your security team work on basically trying to like how to mitigate this without using the cloud and stuff like that. So this is a very this is a very fast movement you should do, because if you don't do it fast enough, you might be just hacked and all your information would have been taken away and stuff like that. So I think I explained a lot about the Log4j vulnerability, so we can just dive into the demo. And if you want to go to TryHackMe, Room, and Solar, this is the exploiting Log4j. Explore CV. This is a CV number. A vulnerable in Log4j affecting almost all software around the sun. Basically meaning that there's loads of, according to Java, there's 3 billion devices running Log4j. I mean, running Java. So this could really affect loads of devices. So I already started the instance. You can just start it, and this is basically the introduction. You can read this on your own. I'm pretty sure I just covered everything which is said here. So we can just this and click this, and we can go to the reconnaissance. So first, the target. We'll read this. The target virtual machine includes software that utilizes this vulnerable log4j package, offering you a playground to explore the vulnerability. After deploying your virtual machine, you should find that the IP address accessible in the TryHackMe VPN or through provided attack box is this. So this is basically the instance IP, what we're going to attack. To begin, just start with the basic reconnaissance. To understand what ports are open on this machine, this is best done within a Linux distribution. You can read this, yes. I recommend using a Linux distribution, because like Kali Linux, Parrot OS. I'm running Parrot OS or Black Arc. Basically, it has most of the security tools already inbuilt. So we can just copy this, and this will basically show us all the ports open on our attacking machine. So we see that there's port 22 and port 111. That's all we need for now. And so we did that. The application present on this target specifically uses ports that may not be identified immediately noticed by Nmap. For the whole picture perspective, scan all ports like so. So basically what it's saying that the application which is running the log4j, it's on a port where Nmap wouldn't immediately notice it. So basically it's like a unorderly port, unorderly, like not a very predictable port. So we can just do tag p tag. This basically allows us to see all the ports, but we can see on here that TrackMe has given the port number away, so just port 8983. So what I'm gonna do is copy my IP address here, copy this, and I'm going to go onto that port and see what's on. So 8983, I believe, and we see it's a Solar admin. So here we can say what service is running on port 8983. Just the name of the software. So this Solar is run by Apache, as we know that. So I'm pretty sure he says on the introduction. But this Solar admin is run on Apache, so we can just write Apache. Let me just spell that. Apache Solar with an A. That's wrong. I think it's this. So that's right. So it's not with an A. It's just SOLR. And now we can go into discovery. Yeah, so it says here this is run by Apache. This target machine is running Apache Solar 8.11.0. One example of software that is known to include the vulnerable log4j. So basically, it's trying to say that this version it's running is vulnerable to log4j, and for sake of showcasing this vulnerability, the application runs on Java. So anything that runs on Java, this version number, I'm pretty sure it is vulnerable to the log4j vulnerability. So it doesn't normally have to be with log4j. It can just be with anything. Explore the web interface accessible at this. So I open that up, and we can just explore this a little bit. Just click around and just feel the thing and go to the official website. So we can just click around and see what this is, but we can see that this is a logging. Basically it's logging stuff, I think so. And yeah, we can just go to dashboard real quick. Yep. So now let's keep on reading. Take a close look at the first page when navigating to this. You should be able to see clear identifiers that log4j is in use within the application for logging activity, which is what is this argument set to display on the front page. So we know that log4j is being used to log stuff here. So what we can do, I'm pretty sure we just go down a little bit. So what it's trying to say is, what is this, the dsolar.log.dir argument set to display on the front page? So we can just search around for a little bit, I guess. We see this opt solar dot slash server, which I'm pretty sure that is right, because it's supposed to display this. Yep. We can try this. We can try this and just paste this. We can see if we're right, and we're wrong. So I'm just looking for this real quick, because I'm pretty sure we download the task files later on. Oh yeah, it's this, the dsolar log.dir. this is what it's supposed to display. The var solar logs. We can just copy that and paste that in, and that should be right. Okay, download the attached file. So let's just download it. We can save the file, and we have downloaded it. One file has a significant number of info entries, showing repeated requests to one specific URL. What is this? Okay, so we can just open this. We can unzip this. We can try this solar.log. Oh, okay. What did I do? Let's just unzip this again, and let's just extract all of this. Extract to the. I made just a little folder for this box solar, and I'm just gonna extract everything in here. Solar logs. So all here we can see. So I'm pretty sure we can just do open solar.log. Okay, we can't view it like this. So we need actual log information. And we see we can open it by a simple gedit. So I just use gedit to open it. So I open the solar.log, and we can quickly go back here. I don't need this anymore. We can go here and say one file has a significant number of info entries showing repeated requests to one specific URL. So we see that this solar.log is just the path it is going to is just the admin cause a lot of time. So we can try that. So solar.log, just solar.log. That's right. And what part of the or URL endpoint is indicated in this repeated entry? So it's the admin. Slash cause. So it's going to admin./cause. We'll just paste this in. And viewing these log entries, what field name indicates some data entry point that you as a user could control? Just a field name. We can control the parameters here, the params. So that's what we can control as a user. So let's just say params, and we got that right. And now time for the proof of concept. So we can just read this. So note that the URL endpoint that you have just uncovered needs to be prefaced with a solar prefix. Then when viewing it from the web interface, this meant that you should visit this. So we can quickly visit that. Link a new tab, and we see this. So this is JSON interpreted data. You notice that params seems to be included in the log file. At this point, you may already be beginning to see the attacker vector. The log4j package adds extra logic to logs by passing entries, ultimately to enrich the data, but may additionally take actions and even evaluate code based off the entry data. This is the gist of the CVE. Other syntax might be fact executed just as it is entered into the log files. Some examples of the syntax are these. So basically this is saying that this is log poisoning. it's going to execute something and on this as soon as it goes into the log. You might already know the general payload to abuse this log4j vulnerability. The format of the usual syntax that takes advantage of this looks like this. So basically, this is GND LDAP. So basically, this is controlled by LDAP, and we can just put anything we want here, and it will execute it. I believe this syntax indicates that log4j will invoke functionally the JNDI or Java naming and directory interface. So GND means this. Ultimately, this can be used to access external resources and references, which is what is weaponizing in this attack. So we can basically access any files through this by external resources or references. Notice the LDAP schema. This indicates that the target will reach out to an endpoint and an attacker controlled location. In this case of this attack via LDAP protocol, for the sake of brevity, we will not need to cover all the ins and outs and details of LDAP here. But know that this is something we will need to work on as we refine our attack. We can skip this. Basically, what it's talking about is how the log4j vulnerability is going to work. And basically, what we're going to do now is to prepare your environment for testing the vulnerability of receiving a connection via your own attacking IP address with the following. And we can see this right now. So we can just see. I'll just close this. So let me just clear my ifconfig, and here this is my tunnel 0. This is my try hack me, and basically what it's saying now is ncat lvnp 999, and basically what it's saying now is to curl this, and we see our syntax here. Our payload is in here. So we can just change all this into our IP address 10.10. No, I'm pretty sure it's 4.32.152. Enter. Okay. Okay, did something. Let me just try that again. Put my IP address in 10.4.32.152, and we see it hanged, and basically we are to get our result. Should work. This is quad 9. Let me just see if I got my IP address right. Okay, we've wrapped the URL in a single quote. We did that. So bash your command line does not interpret as a variable. This you must escape out of. And here we got our response back, and we've got our shell. But this shell, we can't really type anything, and it's just basically bugged. Can try that again. Took an awful time. and we've got our shell here. So yep, so we know that the proof of concept is working, but the shell we can't really interact with. So we can just complete all these. And now we are at the exploitation task. Okay, at this point, we have verified the target is in fact vulnerable by seeing this connection caught in your netcat listener. However, it made a LDAP request, so all your netcat listener may have seen non-printable characters, strange-looking bytes. We can now build upon this foundation to respond with a real LDAP handler. We will utilize an open source and publicly utility to stage an LDAP referral server. This will be used to essentially direct the initial request of the victim to another location, where you can host a secondary payload that will ultimately run code on the target. This breaks down like so. So first we just do this, reaches out to our LDAP referral service, and our LDAP referral service springs board to the request to a secondary. The victim retrieves and executes the code in present. So we're gonna put some malicious code in the thing. This means we'll need a HTTP server, which we could simply host with any following options. So I'm gonna do this. Or if you get stuck following any steps, we have a video showcase on how to. Oh, you can just see that if you get stuck. We can just click. We can just hit this. First order of business, however, is obtaining the LDAP referral server. We will use MarshallSec utility offered by this guy right here. So we can just copy this link and git clone it, I guess. Oh yeah, I need to git clone, and it's cloning MarshallSec. So just it doesn't take that long. Go into MarshallSec, and we see here, and we just wait what he says, what the thing says, and basically we've already got this. Ultimately, this needs to run Java reviewing the. It suggests using survey. You may or may not have success using a different version, but it plays by the rules. We will match the same version of Java used on the VirtualBox. Just hit this and complete that. So first we got a sudo apt install Maven. So this is, I'm pretty sure, the packet manager, which is going to install, I guess. I've already installed it, but you'll have to go through a process, and not that long. And after you install it, we can just spray Maven clean package skip test. So I'm pretty sure just going to clean this package if there's any wrong code and stuff. So make sure you're in the MarshallSec, the GitHub repo that we just cloned, and that. And I'm gonna do with the sudo, and this will take a while. We see now that it finished for me. That's the reason, because I already installed this. So if you haven't done this for the first time, it might take a while. So yeah, this is installed. We can go back here and just completed. And here first, this is how we're gonna start the LTAP server. So basically, this is going to go into our service that we just installed, and there's a LDAP referral server right there, and we're gonna host it, I guess. So just copy this, and I'm just going to run it with a sudo, and it's listening on this port right now. So you have to copy this for the question and paste it and submit, and that's right. So now that our LDAP server is ready and waiting, we can open up a second terminal window to prepare our final payload and secondary HTTP server. Ultimately, the log4j vulnerability will execute arbitrary code that you craft within a Java programming language. If you aren't familiar with Java, don't fret. We will use simple syntax that simply shells out to running a system command. In fact, we will retrieve a reverse shell connection so we gain control over the target machine. Create and move it into a new directory where you might host the payload. First, create your payload in text editor, anything, and with a specific name, exploit.java. So, this is our exploit right now. So basically, it's going to give us a reverse shell. Obviously, we have to change this into our own IP address. So, I'm gonna open split here and cd out of the Marshall sec and just do gedit exploit.java and just paste all the code in. Before you save it, just change this to your IP address 10.4.32.152. That's mine, and we will have to after you modify your attacker, we've done that. For this payload, you can see we will execute a command on the target, specifically this. So basically, we're gonna execute this command here. So we're gonna get a reverse shell to call back to our attacker's machine. This target has been configured with netcat for ease of exploitation. Thought you are more than welcome to experiment with other payloads. So we can just do anything, but I'm gonna stick with this. Compile your payload with this here. So we're gonna compile our payload, and I'm just gonna run that with sudo. And basically, if you get the one warning, it's basically done. And we see we have an exploit.class. After we did that, we can just press done. And now we have to just start up our Python 3 HTTP server. You can use other HTTP servers, anything that you have that you like to do. I'm just gonna stick with the Python one because that's simple for me. And yep, that's running there. Complete this. We can prepare our netcat listener on port 999. That's if depends. I'm pretty sure everyone has port 999. Depends on which port you used on this. And now this is basically the main exploit really right here. So let's press complete on that. So we're gonna split the screen, and I'm gonna cd back and paste this. So basically what it's doing is it is going to reach out to the LDAP service. And the LDAP service is going to reach out to the exploit.class, and it's going to retrieve it and execute it. And basically that's how we're going to get our reverse shell. Just clear this and put your 10 dot your IP address, and we can just press enter. Oh no. the reason why this is not working is that I didn't put a single quotes, and now it's working. We see that the send referral response. Oh, I haven't changed it, did I? We've got this to exploit.class. Okay, we messed up with our LDAP service because we're supposed to put our own IP address here. So 10.4.32.152. It's listening. Clear this. Send that. Now we're gonna get this route, and then we're just going to get this, and we have a connection. So very interesting. We'll just press complete, and we've basically got a connection right now. And this is just some debugging if you get a error or something, which I haven't. We can just do some quick who am I and stuff like that to see who we are. And we are Solar, so type that in real quick. And say if you like to stabilize your shell, I'm pretty sure this only works on Bash, but most people run Bash. Say if you're running SZSG, you have to search up how to stabilize your shell then. So first we just copy this. Basically get a bin bash so it works. Control C, enter STT TTY raw echo and FG and just hit enter and hit enter 2 times, enter, and we can just do export term equals x term, and we have got a full stabilized shell. If I do control C, it's not going to exit, so I can run any programs. We can quit any programs without breaking our shell. Just complete that, and we want to gain root access now. We have got a hold of the machine. Now we want to gain root access, and if we do sudo attack L, we see that we can run everything with no password, so we can just run as user. But let's see what. Yep. So we can just. So what's showing here? We can change the user password if you want with SSH, and I'm gonna have it with SSH. So we can just do sudo bash and password for Solar, and the new password I'm just gonna do SOLR, no capitals, SOLR. Basically the name, the username. I'm just going to use this. So here I am going to complete that. I'm just going to SSH into the Solar. And yes, the password is SOLLR. Let it load, and we're in. So let's complete this now. We're on to the detection. So unfortunately, finding application vulnerable to the CVE log4 shell is hard. Detecting exploitations might be even harder, considering the unlimited amount of potential bypasses. With that said, the information security community has seen an incredible outpouring of effort and supporting to develop tooling, script, and code to better constrain this threat. While this room won't showcase every technique in detail, you can find an more enormous amount of resource online. Below are snippets that you might help either effort. So these are all of the like basically trying to detect this log4shell, log4j, log4shell exploitation if someone's doing it, and to explore our own logs. Use your SSH connection or reverse shell to move into a directory where Solar logs are stored. You already know this part. You gave it as an answer in task 3, so we can go to task 3 and see what. So 1 2 3 discovery, and it's the var solar log, so we can just copy that and we can go into detection. So we can just do cd this, and basically we're here. Review the log file that you know is affected by the log4j vulnerability. We know it's the solar it's a solar.log one. It's that one right there. And notice your JND attack syntax included in the log entries. If you would like to experiment more, try some more bypasses. So we're gonna try and show nano solar.log. And we can try find our basically our exploit, and here we see it, the exploit here. Basically our exploit right here, it worked, and this is how we're getting the shell right now. So yep, we did that. So these are all of the bypasses. You can try this if you want, but I already tried these. These are really fun. You can try them whenever you want to do it. Just mitigation. Now basically this is the mitigation, how we can stop this, how we can prevent this. So in the solar, if you're running Apache Solar, there's a pretty easy way to mitigate this. We're gonna try that right now. So clear that, and basically we can just locate the full path of solar.in.sh. So we can just say locate solar.in.sh, locate, not locate, and we see that we find 2 directories. We're gonna go with the etc default solar.in.sh because that's the right one. We're gonna paste this. The Apache Solar website security page explains that you can add this specific syntax in the solar.in.sh file to modify the yeah, we need root privileges, so we need to copy this. So this is what we modify. We need root privileges, so we can just do sudo su, and we're root right now, so we can just do nano we first have to cd into this though, to cd into that. It's not a directory. We can just do nano this, and basically what it says here is to modify this text editor you'll need sudo prefix to borrow root privileges if you are not already root. Scroll to the bottom of the page and add a new line and do the syntax. So scroll to the bottom of the page, and here it is. We can just copy this, and this is what is preventing, I guess, the exploitation. Remember to add a new line at the end. We've done that, and we could just have to restart this. Restart and just restart that. And now it is waiting up to 180 seconds to see Solar running on port 8983. To validate that the patch has taken place, start another netcat listener, as you had before, spinning up a temporary alert. So basically do everything that we just did, and we gotta try to do it again and see if we mitigated the log4 shell exploit. So we need to exit this. So what happens? Just split horizontally. So we can just leave everything on here. Netcat tag lvnp 9999, and I guess we can try to do the export again, see if it's working. And we see it not even going to the LDAP server, so we know it worked. We know it did not even send it, because that's what it was supposed to do, and so we basically made it work. So if you need a refresher, we can just do this. You should see there's no request is made out of your temporary LDAP service. We did see that constantly. No request in the HTTP server, and no reverse shell sent back to a netcat. So verified that the Apache Solar incident has now been mitigated against the log4 shell. So we just mitigated against the exploit. So now patching. You can just read this through. Basically, pretty sure it hasn't still the Apache Solar hasn't been a formal patched for SV this for the severity, because there are loads of bypasses and stuff like that. So we'll just complete that, and yep, so we could do that. So special thanks to TryHackMe and John Hammond for creating this awesome room. And if you want to know more about the Log4j exploitation, I recommend checking out John Hammond's latest video. It's about like his Log4j and how he exploits Minecraft through and opens up calculator in his attacker machine and stuff like that. So victim machine, I mean. And so yep, I guess that's it. So hopefully you guys had fun, and this is a really nice box. You can check it out, and see you guys next time. Peace.